Statistics gets a bad rap for having the ability to manipulate data to support any position. I don't know how many of you pay attention to politics or political issues, but, I hear both Democrats and Republicans claiming that the other side's data or statistics or whatever is misleading or manipulated or things like that. And one of the methods that we can use to distort truth in statistics is through graphs and graphics. So we say a graph is misleading if it unintentionally creates an incorrect impression. If, however, the graph purposefully creates an incorrect impression, we call that kind of graph deceptive. So the difference between misleading and deceptive is intent. If it was accidental that they created an incorrect impression, then it's misleading. If it's deliberate, then it's deceptive. So it's important to be able to recognize misleading and deceptive graphs. The most common graphical misrepresentation of data involve the scale of the graph. An inconsistent scale or a misplaced origin. And we'll talk about what all those things mean in a minute. Increments between tick marks should always be consistent, which means the same distance apart. And scales for comparative graphs, so for comparing two data sets, should always be the same, because otherwise it makes it hard to compare. Also, because readers assume that the baseline or the 0 point is at the bottom of the graph, a graph that begins at a either higher or lower number can be misleading. So, for example, a home security company located in Minneapolis, Minnesota, develops a summer ad campaign with the slogan, "When you leave for vacation, burglars leave for work." According to the city of Minneapolis, roughly 20% of home burglaries occur during the peak vacation months of July and August. The advertisement contains the graphic shown. So let's look at this and decide what's wrong with it. There are several things that are wrong with this graph. First of all, let's look at the percentages here. We have July and August is 20.19%, and all other months is 7.98%. Well, first of all, the categories are not the same, right? They're not the same time scale. So July and August is 2 months. The rest of the months then, there are 12 months in a year, so other months is a time period of 10 months. So how can we really compare 2 months with 10 months? Okay, what's another problem? We've got these two percentages I talked about. You would think that the percentage should add up to be 100, right? But they don't. So something's missing, or something's wrong, but they should add up to be 100%. Well, maybe it's 7.98% for each one of those 10 months. So if we do that, we would have 7.98 times 10. That would give us a total of 79.8%. But if this 7.98% was for each month, then the 20.19 should be for July, and there should be another 20.19 for August. If that were the case, we would have over 100%. So something's weird with the percents here. And what they've actually done is the 7.98% is for each of those 10 months. But they got that 20.19% is July and August added together. So the question is whether or not this is misleading, meaning it was unintentional, or whether it's deceptive. And the key to figuring that out is to know who generated this graph. So this graph came from a home security company. So I would say that makes this graph deceptive. And the reason I would say it's deceptive is because this home security company is probably deliberately trying to scare you into buying their service, right? So the company is trying to profit. Which probably means that they're deliberately misleading people. And remember, we say it's deceptive if it's deliberate. We'll end this video here, and we'll look at some other examples of misleading and deceptive graphs in the next video.